Module 5's the transform analysis of LTI systems. The Z transform plays an important role in analysis of discrete time systems. The transfer function of a system, let's say x of n is the input and y of n is the output, and with the transfer function h of n, then we can write its transfer function as y of n is equal to h of n in convolution of x of n. So y of n can be written in this fashion. Then when we take the Z transform of this equation, so we get y of z for y of n, and h of n convolution x of n is nothing but h of z into x of z, because convolution in time domain is multiplication in the z domain. So it is y of z is equal to h of z into x of z. So it is a multiplication, so which makes many of the solutions easier, and we can find the convolution of any signal given by converting that one from time domain to, by translating that one from time domain to z domain, and again finding the result and going for the reverse conversion. So one can have the convolution done just like a multiplication in the z domain. So we need to see the problems in relation to this. So very first problem, let's consider this problem so that how it can be solved. We'll see. We need to represent the system as, let's write the system having its transfer function as h of n with input x of n and output as y of n. So this y of n is given by x of n convolution h of n. So when it is converted to the z domain, which can be written as y of z is equal to x of z into h of z. Now we need to find x of z and h of z, so that we need to go for the further simplification. Now we are given with x of n and y of n, and we are being told that a causal system has input x of n and output y of n. Find the impulse response of the system. So the impulse response of the system is nothing but h of n. Now we are given with x of n and y of n. So let's see what we have to do here. So x of n is given, means we can find its x of z, and similarly we can find y of z from y of n. So let's do that. From the given x of n, we can write x of z for this. So x of z for this problem is given, or is being calculated as, we know that x of n's z transform is x of z. So del of n's z transform, if one can remember, del of n's z transform is 1. When we take del of n's z transform, we got 1 it as, plus 1 by 4 del of n minus 1 z transform is 1 by 4 z raised to minus 1. And similarly, minus 1 by 8, this del of n minus 2 z transform is z raised to minus 2. So we get this, it is z raised to minus 2. Similarly, we go for finding what is y of n's z transform. So let's write it here. Y of n's z transform is y of z. Here del of n is there, so the z transform of del of n is 1. Then the next sign is minus 3 by 4, and del of n minus 1's z transform is z raised to minus 1. So we use this equation. Now here we are given with x of z and y of z. So x of z and y of z are given. So here so y of z is equal to x of z, h of z. So we can write h of z from this. We can write h of z is equal to y of z divided by x of z. So let's substitute these values. Y of z is nothing but 1 minus 3 divided by 4 into z raised to minus 1 divided by, now x of z is this one. We can write it as 1 plus 1 divided by 4 z raised to minus 1 minus 1 by 8 z raised to minus 2. Now as the numerator's power is lesser than that of the denominator's power, no problem, we can go ahead with the partial fractions. First we need to factorize and get the roots of this equation. So let's write this one as 1 minus 3 by 4 into z raised to minus 1 into z raised to minus 1 divided by this 1 plus 1 by 4 z raised to minus 1 minus 1 by 8 z raised to minus 2. Let's see how to obtain this. So it is 1 plus, it is 1 plus 1 by 4 z raised to minus 1 minus 1 by 8 z raised to minus 2. So we write this one in the, so when we go for factorization, so this equation can be written in this fashion. And to factorize, so we need two numbers which when multiplied 1 into minus 1 by 8, when multiplied they should result into minus of 1 by 8, and when they are added the result has to be 1 by 4. So the answer would be 1 by 2 and 1 by 4. When they are multiplied they give plus 1 by 2 minus 1 by 4, they will give minus 1 by 8, and when they are added it will be plus 1 by 4. So after factorization we get these values. So let's write these. So it is 1 minus 1 by 4 z raised to minus 1 and 1 plus 1 by 2 z raised to minus 1. So these are the two roots. So for this equation we have to go for finding the partial fraction constants. So let's express this one as k1 divided by 1 minus 1 by 4 into z raised to minus 1, and the second one can be written as plus k2 divided by, this k2 divided by 1 plus 1 by 2 z raised to minus 1. So when we go for finding these constants, we get the value of this k1 is 2 by 3 and minus 2 by 3 and plus pi by 3. So it is minus 2 by 3. The value of this k1 is minus 2 by 3 and this k2 is 5 divided by 3. So let's write this as our h of z is equal to minus of 2 divided by 3. This 1 minus 1 divided by 4 into z raised to minus 1 plus 5 divided by 3, 1 plus 1 by 2 into z raised to minus 1. So this is our impulse response in the z domain. Now when we go for finding taking the inverse z, when we go for finding the inverse z transform, the inverse z transform of this h of z would be h of n is equal to minus 2 by 3 will not be changed. And to write these into the time domain, we need to know that a causal system means it is always a right-handed system. Causal system has input x of n and output y of n. So a causal system will have a right-handed sequences. A system is said to be causal if it is right-handed, means both of these we need to write as right-handed, means 1 divided by 1 minus 1 by 4 into z raised to minus 1 can be written as 1 by 4, because 1 by 4 raised to n u of n's z transform would be 1 divided by 1 minus 1 by 4 z raised to minus 1 into u of n, because it is right-handed. We need to remember that a causal indicates a right-handed system. So plus 5 divided by 3 plus 5 divided by 3. This 1 divided by 1 plus 1 by 2 z raised to minus 1. So usually we have minus sign, here it is plus. It indicates that it is minus of 1 by 2 raised to n into u of n is the representation. So the impulse response of the system is nothing but this one. So which can be proved, it is 2 by 3, 1 by 3 is being taken common, and minus 2, 1 by 4 raised to n, and it is minus 1 by 2 raised to n u of n. Similarly, one can solve the other problems also. So straight away we go for stability and causality. So we can see those in the next video.